Hello, can you hear me now? Hello, hello, scholars, can you hear me? Hello.
Hello, we can hear you.
Okay, how are you today?
I'm fine. How you doing?
Good, good. So, today we'll
Oh
complete.
yeah. Play it on your phone, bro. It literally like, bro.
So today we finish the confidence interval, and then we move. We'll introduce you to test of hypothesis. Um, so let's begin. Before we start, I want to show you what is due this week. Basically, I think the assignment from last week are the main one that are due this week. Because remember I said you can start working on them this week. So other ones are due the following week, but I'm going to show you exactly what I mean. Let me close this. Hope you can see the screen. Now, if you look at that announcement, excuse me, you will see that it's only two assignments. The one that I do last week, that I put in last week, you can complete them this week. I think I explained that last week as well. So these are the new ones, and they are due on May 10th. Homework 9 and homework 10. Then last week I put a project. That project is due this Sunday, just like other ones. Let me take you to the modules where you can locate them. Excuse me, sorry. I remember that I mentioned, yes, that see, you can see the screen. Test 2 is due this week. I put them in last week, but I say you can start them this week after tonight's class. Homework 8 is also due this week. Then projects due this week. So on Sunday, I do on Sundays. The project, I put the video there, so we just watch the video. It is based on the confidence intervals. So we just watch the video and then follow the step by step. When you finish, upload the spreadsheet for me. Okay? But for this week, homework 9 and homework 10, they are due on May 10th. So you have not enough time for those. Now, let's begin. Like I said, we finished confidence interval. We already done for confidence interval for the mean. Now let us do the confidence interval for proportions. Okay? For proportions. As you can see from the screen, when we say proportion, we are referring to a part of something, a part of the whole. So here are some of the, excuse me, this is something. Paper. All right. Okay, I'll use this one. Yeah, I'll use this one. So here are some of the key terms we use. But again, proportion simply means part of a whole, a part of something. Like we can say 10% of all the students. See, all the students in Morgan, 10% of them. So part of it is the proportion. So the key terms we use here are when we're doing confidence interval proportion. The P itself is the population proportion, the one we're trying to estimate. Then P hat is the sample proportion. I call it P hat. And the formula for P hat is X over N. The X and N will be given on the equation. Yeah. So that the Q is 1 minus P hat. Q hat is 1 minus P hat. Now, to get the error for proportion, we use this formula here. Z alpha over 2, which is the critical value, times square root of P hat times Q hat by N. And once we get the error, we subtract the error from the left side to get the lower interval, and we add it to the end to get the upper interval. Last week I showed you how to get the critical values. So again, once you get the error, subtract it from the left side to get the lower interval, add it to the right side to get the upper interval. Then we can now conclude uh, what the result tells us about the confidence interval. Now, like I said, last week I showed you how to get the critical value, but for confidence interval, the critical value is always a two-tailed test because it has two sides, lower side and upper side. So I'm gonna type in the Excel formula we use for getting the confidence interval for critical value for two tails. So let me type it here again, and we can use that. Oh, as a matter of fact, I can type it in any case, let me just type it, then we can go to Excel and get it. Equal. We have norm.s.inverse. Oh, excuse me. Norm.s.inverse. Opening parenthesis. We have then put the because it's two sides, so it's going to be 1 minus alpha is given. You get it alpha, so just alpha over 2. Alpha. Let me just call it alpha. Write it as alpha over 2. Okay. Then and then comma. That's it. As a matter of fact. 1 minus alpha over 2, not alpha. 1 minus alpha over 2. Sorry, my mistake. 1 minus alpha over 2. Okay. And then you get let me highlight it. So first thing is to put these things in Excel, and we get it together. So I'm gonna copy this, and then take it to Excel where we can paste it. Okay, I'm gonna add a new I'm gonna paste this right here. Okay. All right, maybe with good values. Okay. Now again, let me put the formula here for it so that we can. I'm looking at it as we do it. Okay. I'm gonna copy this. Now, take you back to that place just to refresh your memory how to get the critical values. Now we have, I'm going to insert the formula on one side using this chart here. I'm going to Control V. I'm going to increase the size, make it a 18 bold. So that's one right there. So let's get it. For this one, for 90 degrees. So 90%. I mean, the alpha is, if you're 90% confident, the chance of being wrong is 10%. So the alpha is 10%, which is 0.1 in decimal form. For 95%, your chance of being wrong is 5%, which is 0.05 in decimal form. So for 99, it's 0.01 because the chance of being incorrect, wrong is just 1%. This one is 0.08, 0.02. Because your chance of being wrong is 1%. So now you cannot apply this formula. So equals norm dot s dot inverse. Okay. 1 minus alpha over 2. Okay. And close the parenthesis. And press the enter key to give you the confidence, the critical value. Now you can just copy it down to calculate the rest of them. And you can now change them to decimal places. Okay. And that's it. So that we have we can just now we have the table, we can just highlight it, copy it, and then paste it here so that we have everything we need. Okay. I can just delete this one. Let me see what I can do. Okay, let me see how I can delete it. I can just move it down. Okay, let me just undo this because it won't let me. Let me just remove it completely and then paste the new one right there. Yep, paste the new one right there. That's better. So we have it. Very easy. Now with this, now we can now do some questions on confidence interval for the proportion. Now look at the first question we're going to solve here. It says in a random sample of 200 investment advisors, 70 were recommended information technology stocks. Now, give the maximum error with 95% confidence, and then construct the 95% confidence interval for the 3-minute proportion. Well, it said, let's put this, we get all this, even the error, we get it from Excel. So we put this in Excel. Let me write them down so that I can enter them in Excel. Question number 12. X is, I can even write them down here. Your X equals, here P, okay, equals, that's P hat. I call it P hat. The P hat, okay, equals X over N. So let me put N before P hat. N, oh, it's small there. N equals, okay, N equals, now, okay, you say in a random sample of 200 investment advisor, 200, 70 recommended. Out of this 270, which is the X recommended. So, then P hat will be X over N. If you remember, I told you the formula right here, X over N. This is what it's asking us to find the error, maximum error. Okay. So, so we have our S. So that P hat will be X over N, which is X divided by N, which will give us actually 70. I wrote 70 and 7, which is 70 divided by N. So like I say, we're going to do this in Excel. So then it says, and for 90, it says for 95% confidence. So our critical value is Z alpha over 2, Z alpha over 2, alpha over 2 equals, we got it here for 90%, for 95%, we got it here already, 1.96, 1.96. That's all we need to put there. So we'll go and add them. We'll go and add them there. So I'm gonna write them down. X is 70, N is 200, Z alpha over 2, this critical value is 1.96. P hat is, we don't know, we'll find it from that place in Excel, and the Q hat. Then we can now find the error. So let's go and put it in Excel. Okay, not this one anymore. Make sure I send it. So we have okay. So we have this here. We have N is 200. Actually, X is 70, N is 200. Okay, so we can calculate the P hat and Q hat. P hat equals X over N, which is 70 divided by 200, equals 0.35. Okay. Yep. So the Q hat is always 1 minus P hat. Okay. Q hat is 1 minus P hat. So I will show you on the Word document. I wrote it there. You can see that Q hat is 1 minus P hat. So, okay. Now we can just go and put it right there. Equals, of course, you know when you put equal sign when you want to do work in Excel. 1 minus the P hat, which is this one here, 65. Okay. Now, we need to get the error because the question asks us to, it says, give the maximum error with 95% confidence. Okay. So this is where we're going to find it. Okay. So, I will say, I'll call it, maybe, I think I'm going to, remove some of these spaces here. Okay. Let me remove this and type, error right there. Critical value. Okay, let me type, critical value is the alpha over 2. I'm going to put it right here. Right here. I'll put it right there. Then I put it at the wrong place. Okay. Confidence level. Confidence level. Then critical value. Yeah. Critical value. Okay. Oh, as a matter of fact, I'm gonna put alpha. They're not alpha. Alpha here. Good. Then critical value now becomes here. Okay. So with that, we can now find the error. Error margin E, lower interval, and then upper interval. This will be the new we are doing it. Okay. We're looking for 90%, 95% confidence interval for the proportion. Say, yeah, 95% confidence interval. So our critical value, our alpha is that means the chance of us being wrong is 5%. So confidence level is 95%. Okay. Can just call it 0.95. So that alpha becomes 5%, 0.05. So that we have critical value equals, we have it already, but I'm just going to put the norm. We have it on okay, equals norm dot s dot inverse 1 minus alpha over 2. Okay, 1.96. Yeah. Yeah, that's 1.96. Now, the error margin becomes, you can see the formula right here. Let me bring it under so you can be seeing it as you do it. So it says z alpha over 2 times p hat times q hat over n, which is equals the critical value z alpha over 2, which is this one right here, times okay sqrt and square root of, okay, P times Q over N. P hat is this times Q hat, this, okay, close parenthesis, divided by N, which is 200, then close it finally. So once you press the enter key to give you the error margin, 0.066. I want to make all this into the 3 decimal places. Okay. So now we answer part A, margin of error. So that's what they ask us in part A. Part A says give the margin of error with 95% confidence. We just answered it now. So once you got that now, we can now get the interval. Lower interval will be P hat minus error. Upper interval will be P hat plus error. So we have just finished it. So we got here we got equals P hat, which is right here, minus the error, which is the error. Give us the lower interval, and the upper interval equals P hat plus error. Okay? Because they want us to find 95% confidence interval. So now, once we get it, we can now I will have it right here. We have the interval, the upper and lower interval. Let me give it a green color. So now we have this. I can just copy it. Okay. So that we can interpret it. And then copy it. Go to our workbook in Word, and then paste this right here. I'm gonna make it a little bit bigger than that. Probably 18, and then expand it. So this is our answer right here. So now this 0.284 means 28.4%, and 0.634 means 63.4%. Okay. So we are 95% confident that between 28.4% to make sure I added this. Let me just double check the math in Excel. Okay, for X bar plus X bar, which is 35, plus error, which is right here. Oh, 41.6. I added the wrong thing there. That's why 41.6. 41.6. Yeah, there's okay. 41.6. So we can say with confidence that between 28.4% to 41.6% of investment advisors recommend IT stocks. So any question on this? Any question? Okay, there's no question. Good. So, and the good thing about Excel, once you use it for one, you can use the same formula for all of them. That's the good thing about Excel. So, having said that, we can try another example of this type. Since we have done this one, we can just use the same template. I'll call it now. It is not a template. We can use it to answer the rest of them. Somebody just came in. Let me just mark the name. Okay. I don't even see the person here. Oh, I see it. Okay. So since there's no question, let's do another one example. You see, in a random sample of 300 teenagers, 190 have cavities in their teeth. if a sample, let me move this down so everybody can see it very well. And then, okay. Another sample of 300 teenagers, 190 have cavities in their teeth. If a sample of if the sample proportion of teenagers with cavities is used as an estimate of the population proportion of teenagers, give the maximum error of with 99% confidence. B, construct a 99% confidence interval for true proportion. All right. Solution. Yeah. Let me make this in 18. So I'm just going to copy some of this thing from here, the x and the alpha over 2. Okay. Okay, the alpha over 2. Okay. Our solution. So our x here is in a sample of 300 teenagers, 190. So our x is 190 this time. Our n is of 300 teenagers, so n is 300. The alpha over 2 for 99%, we're going to find it. We have it already, as a matter of fact. It is that was says for 99%, we have it at 2.58. 2.58. I showed you already how to use the Excel to get it. So since we have it already, I'm going to put it to here 2.58. 2.58. So I'm going to write 2.58. 2.58. So let me write this down, and then we can go and put them in a cell, and it will give us the answer right away. So I got x is 190, n is 300, z alpha over 2, which is the critical value, is 2.58. So let's go to Excel and put all these things. Now, like I said, since we've done the calculation already, all we need to do now is to just copy this from here and paste it here. Then as we put the numbers, it will be changing. The answer will be changing. We don't need to start calculating it again. Just copy this and use it. That's the good part of Excel. This time around, our x is 190. So I'm going to put 190 here. I want you to be watching the answer as I'm doing it, because you see the answer will be changing until we put the last. The only thing we need to change here is the alpha. Sorry, yes, the alpha, and then the confidence level and the critical value. And it will give us the result right away. So this one is 190. So I'm going to be 190. So this one is 300. Okay. So you can see this. See, it will be calculating them as I do it. Confidence level is 99%, 0.99. Alpha is, because if you're 99% confidence, your chance of being wrong is 1%. So alpha is 0.01. Okay. So once I change the alpha, it will calculate the critical value right away, 2.58 approximately. So if I change all this to, okay, if I change all this to 2 decimal places, it will give me 2.58. See? So now it gave us the answer right away. Right away. So it calculated the margin of error. So now this is the new confidence interval. So I'm gonna copy this. Our new margin of error and a new confidence. I'm gonna copy this, and I'm going to put it under here so we can finish the equation. Okay, making it okay. Yeah, you can see the answer. So I'm gonna remove this middle one because we don't need it here. So we just have everything we need. So conclusion, I can just copy this and change the numbers. Okay. The conclusion. So we are 99% confident that because this is about to construct 99% confidence interval for the true proportion. Okay. Okay. So that the true proportion of teenagers that between have cavities in their okay. Yep. I'm gonna take this in there. Okay, good. So we can say with confidence that between 56.2% 56.2% to 70.5%, 70.5% of the teenagers have cavities in their teeth. And that's it. So this one is more direct, more straightforward. Any question on this one? Any question? Okay. See. All right, good, excellent. Now, sometimes they will not give you they will not give you the like you can see the way they did this one here. The first one we did, they developed 300 teenagers 190 have cavities. And in the first one, they tell us that out of 200 investment advisors, 70 recommended IT stuff. So sometimes they won't give you the X like that. They'll just give you the proportion it said as a percent. Like if you look at this last question here on this page, it says a survey. I'm gonna move it down so we can see. Say that a survey of 200 boat owners found that 12% of the pleasure boats were named Serenity. So they didn't give us the X. They just give us the proportion as 12%. And it says find the 95% confidence interval for the true proportion of boats named Serenity. 95%. So that makes us make it easy for us as a matter of fact. We need that p hat. They give us the p hat. P hat equals 12%, which is 0.12. Then Q hat. They didn't give us X, so we don't need to put X. Q hat is always 1 minus P hat. So we can get that from the Excel. Now for Z alpha over 2, Z alpha over 2. See, for 95%, we have it here already. As we calculated it earlier, the first one we calculated, I think, 1.96. 1.96. So we're going to put it there, 1.96. 1.96. Now let me write this down so we can go and compute it. So you have P hat is 0.12. Q hat, you find it over there. The Z alpha over 2 is 1.96 to 95%. So we just go there and copy this and put it there. So let's go and put it right there. So like I say, in Excel, if you want to do the first one, you don't need to start calculating again. I'm just going to copy this and paste it right here. Okay. And then once I change the numbers, it will recalculate. So in this case, there's no there's no appear. So our sample size. Oh, I didn't get the sample size. Let me get the sample size. Sample size is n equals is it 200,000. N equals 200,000. Okay. So I'm going to go there and put it right there. So I got p hat is given as 12%, 0.12. It will calculate the Q hat right away. And this is 95%, 1.96. So this is the critical value. So margin of error. This is why we're going to do some work, because I removed the x and from that and n here. So I don't put. Let me put the n. I know it's 200,000. Okay, he calculated everything. So I have let me make sure I have everything in. Okay, everything. Okay, I think everything is in. Now I'm gonna copy this and paste it there, and then we can answer the question. Okay, paste it right here. And I'm gonna make it 18. Okay. Oops. Okay. So this is the maximum error. Where's my error? Okay. Let me move it down. It just went to the next page. Okay. So you can see our error if I see the confidence interval. So I'm going to remove this two in the middle, because those are not the one we're looking for. So I'll remove that. Okay. So this means this one means 11.9% and 12.1%. So we are 95% confident that between 11.9% to 12.1% of the pleasure boats were named Serenity. Okay. So that's how you get it. The confidence interval for proportion. Now the next thing we need to examine will be how to find the minimum sample size for proportion. That one is the easiest, as a matter of fact. The formula we use for that is right here. P hat times Q hat times Z alpha over 2 over error raised to the power 2. So sometimes you may not have the approximation. You may not be given the approximation for P hat. In that case, you can use 0.5 for P hat. But in most cases, you should be given the approximation P hat. Now let's try one example like that one here. If you look at this, it says a researcher wishes to move this down. A researcher wishes to estimate with 90% confidence the proportion of people who own home computer. A previous study shows that 40% of those interviewed has a computer at home. The researcher wants to be accurate within 2% of the true proportion. Find the minimum sample size that is necessary. Okay. Firstly, you want to 90% confidence. So that Z alpha over 2. Do we have 90%? Let me make sure we have it. If you don't have it, we can just calculate it. I don't know if it's among the one that we calculated. Let me see. Yep, it's right there, 1.64. For 90% confidence, Z alpha over 2 1.64. Okay. So we have it then. So we go down. So for this researcher, say you want to estimate with 9% confidence the proportion of people who own home computers. A previous study showed that 40% of those interviewed had a computer at home. The researcher want to be, actually within 2% of the true proportion. Find the minimum sample size necessary. So again, Z alpha over 2 equals 1.64. 1.64. Okay. Then we have 90. That's okay. Take care of 90%. P hat is say want to say that a previous study shows that 40% of those interviewed had a computer at home. So P hat is 40%, which is 0.4. And Q hat is always by 1 minus P hat. Q hat equals 1 minus P hat. No matter we get it from the Excel, but actually this one I can estimate this one. If it's 40%, then Q hat will be 60%. That means 0.6. Okay. Now then the error is it said that you want to be accurate within 2%. That means error E equals 2%, which is 2%, which is 0.02. Okay. Let me write this down so we can go and put it into the formula and get the answer right away. So P hat is 0.4, Q hat is 0.6, error is 0.02. So we can go and put it in and then get the answer right away. Remember that the formula is P hat times Q hat times Z alpha over 2 over error squared. Okay. Let's go and put it in. Okay. I have it right here. So we have million sample size. This is if the I'm gonna use so in sample X, okay, S over N, if they give you a proportion. So they didn't give us that, so we can just start from here. Sample size N. Don't have this, okay. P hat is I don't even need we don't need this part. Okay. P hat is we got P hat as 0.4. Q hat is 1 minus P hat equals 1 minus 0.4. Let me this. So this part, I'm going to remove this, make some modification here, and remove this, and type confidence level, and type alpha. Okay. Critical value. Okay. Error margin. Error margin. Okay. Minimum sample size. Okay. Just my adjustment. All right. So let's do it. Let's do it. Equals. And the confidence level is what's the confidence level again? Look at it. 90%, so 0.9. 0.9. Alpha will be equals 1 minus that. Okay. Critical value equals norm dot S dot inverse. Okay. 1 minus half over 2. Okay, I just make this 2 decimal places so that error become equal equals p hat. You can see right here, p hat times q hat times z alpha over 2 by error squared. So you got p hat times q hat times, okay, we got I'll put it in this form. Z alpha over 2, this one here, over error. I think I made a mistake. It's like all over. Remember they say error. Remember they say the error is 2%. So I'm gonna put the error right there. 0.02. So that we have this now equals p hat times q hat times, okay, z alpha over 2 over error squared. Okay, we use the cap thing to represent squared. Okay, once you press enter key, it will bring up the sample size 1600. Highlight it. Okay, so that should be minimum sample size. I'm gonna copy this and then paste it out. So this means I'm gonna show you what it means. Okay, this is the minimum sample size. Okay, make it 18. All right, okay. So that means we need how many? Is it n is 1623.3326. So that means we need always round it up to the next whole number. We need 1624 samples. Or even it. Okay. So that's it. Any question on that? Okay, no question. So now, I mean, you can try this once as a practice at home. Let us now go to, with this, we have concluded the confidence interval. Now, let me introduce you to test of hypothesis. Okay. Introduce you to test of hypothesis. I'm going to close this one as well. All right. Test of hypothesis. I'll open it now. We're not going to run any tests today. I'm just going to introduce you to that. And then we can go from there. Next week, we can now complete the test of hypothesis lecture. Okay. Hypothesis testing. Okay. And then we also need this one. Okay. No, we're not. Okay, we're finding critical value. We're just gonna discuss how to find critical values. Okay, critical values. Okay, good. Hypothesis testing. I want to get the, got it right here. So now I can close that section. Now I can, I have these two. I can now share it. Okay. Hypothesis test. Now, I'm sure you must have had this word before. So when we test hypothesis, what we are doing is to make a claim and then test the claim. That's basically the simplest way to explain it. In statistics, a hypothesis simply means a claim or a conjecture about a population parameter. Again, when we say population parameter, we're referring to things like the mean, population mean. Okay, I will highlight it for you. Our population standard deviation, our population, so we can test hypothesis on those things. So the step we normally use is to define the population parameter and specify it, Now, then we state the hypothesis that we need to investigate and give the level of confidence or significance level. Usually we use alpha 0.05 or alpha 0.1. I mean, you know this already from confidence interval. Then we select a sample from the population. Then after that, we can collect data from that sample. Once we finish collecting data, we now perform the calculations required for the test and then reach a conclusion. So this explains what we do in hypothesis testing. So you can use it to answer so many questions. For example, question like, does a particular medication lower patient blood pressure? Does acid bath reduce the severity of injuries that are caused by accidents? For real? And so on. So that kind of question can collect data from a sample by population and target population. Now, types of hypothesis. We have the null hypothesis, the alternative hypothesis. A null hypothesis simply means a statement that the value of a population parameter is equal to some claim value. So normally we state the null hypothesis using some, kind of equality sign, like something like equal to, not greater than or equal to, less than or equal to. Now, the alternative hypothesis is saying the opposite of what the null hypothesis is saying, and we normally state it using not equal to symbol, or greater than symbol, or less than symbol. So, we make errors, when we do, sometimes human beings are prone to error. So we cannot, even in their DNA test, they won't tell you 100%, they will say 99.99%. The baby is 99.99% yours, something like that. So anyway, what kind of error would we encounter? First one is type 1 error. Now, in type 1 error, this one occurs if we reject the null hypothesis that is true. That's when it happens. If it's true and we reject it, we committed type 1 error. Type 2 error occurs if we do not reject null hypothesis, that is when it is false. We committed type 2 error. I will use the legal system to explain it. But this would be a small a matrix that we can make it even more clearer. If the HO is true and you rejected it, you have committed type 1 error. 1 error. I'm going to make this into be bold. So if it's true and you reject it, type 1 error. If it's true, if it's false and you reject it, you made a correct decision. Okay? If the HO is true and you do not reject it, you made a correct decision. Then, if it's false and we did not reject it, you committed type 2 error. Okay, so that is it. So having said that, I will take you to how to state hypothesis. Again, like I said, when you're stating hypothesis, null hypothesis, we use some type of equality symbol to state the hypothesis, null hypothesis. Alternative can use not equal to, less than, greater than, but null must be equals or greater than or equal to or less than or equal to symbol. Let's try this. I say a researcher thinks that if expectant mothers use vitamin pills, the birth weight of their babies will increase. Say, look, say will increase. Will increase. So the average birth weight of the population is 8.6 pounds. But it will increase. So you're gonna have HO and H1. HO is null hypothesis, alternative hypothesis H1. Okay. So we increase, and that means less than, sorry, greater than. And you can use greater than only in the alternative hypothesis. So, and this is for birth weight, average birth weight. So it's gotta be mean. So symbol will be a symbol of mean. Mean is greater than, excuse me, 8.6 pounds. That is the claim they are making. That that vitamin will, cause the birth weight, average birth weight to increase. So this is the type claim right there. That's the claim right there. Now H1, HO will say the opposite. Both of them say the opposite of issue, what the other one is saying. Now, that means it's going to be HO less than 8.6 pounds. But unfortunately, we cannot use the less than symbol in HO. So you can just put HO mean, can only use less than or equal to 8.6 pounds. Now, some books use only equal sign for null hypothesis. It is still correct. You can just write it like this. Can say HO mean equals 8.6 pounds, or HO and H1 mean equal. So which of them is more correct? Both of them are correct. So some books, some authors use equality sign for H or HO. I mean, some kind of equality must be there. That's the main principle. Anyway, I think you get the point. Look at this one, engineer. Say the engineer claimed that the mean number of defects can be decreased in a manufacturing process for compact discs by using robots instead of human beings. Excuse me. The mean number of defective tasks is 18. I said he claimed that the number of defects can be decreased. Okay, can be decreased in a manufacturing process for compact discs. So that's the keyword there, can be decreased. So now we have I'm gonna paste this thing here so make it easy for us. Can be decreased. So I'm gonna, move this, and move this. Decrease, that means you can only less than symbol, and you can only use it in the alternative hypothesis. So less than 18, that is his claim. This one will say the opposite. I mean, it can be say mean is greater than, but you cannot use greater than symbol in null. So you can use greater than or equal to. So in Gabin is mean is greater than or equal to. Where is it? Right here. It. Any question, guys? Any question? Okay. Now, so that's different ways of sitting, can go on. Now, this one says, a psychologist, I want to tell you something else. This is, you see where the claim is, you can see that this is pointing to the right side. So we call this right-tailed test. Like, right-tailed test. Now look at the claim here. And the second one we just did, you can see the claim. And the symbol is pointing to the left side. So this is going to be left-tailed test. Now look at this one. It says, a psychologist feel that playing soft music during a test will change the result of the test. Will change. The psychologist is not sure whether the grade will be higher or lower. It's not sure. All he knows that it will change. In the past, the mean score was 75. So he wasn't sure. So you're going to be in this form. I'm going to put this here. Okay. Okay. Will change. It doesn't know whether it's going to be higher or lower. So that means not equal to 73 because we don't know. So we're going to be mean is not equal to 73. Because he said you can change it, but you don't know whether it's going to be higher or lower. So the opposite will be equal, mean equals 73. So because it can be either way, left side or right side, we call this two-tailed test. Okay. Two-tailed test. Now, any question on this? Okay, no question. Now, hypothesis, it can even be for proportion. That's not stating hypothesis. You can even do it for proportion as well. For example, here, it says at least 70%, 45% of senior citizens wear hearing aid. See, that is not averaged. That is a percent. So at least means greater than or equal to. So in that case, we're not going to use mean, we're going to use P. So at least that means greater than or equal to, 45%. I can call it 0.45. That is where the claim is. Now, note that the claim can either be in the null hypothesis or in the alternative hypothesis. It doesn't matter. It's not always in the alternative, like with the other one we did. Yes, even here, the null hypothesis can also be, the claim can also be in the null hypothesis. Just like by coincidence that the other ones we did, it is in the alternative. So the same thing here. So the opposite will be P less than, okay, 2.45. So that's it for proportion, how to state hypothesis. If it's for proportion, use P. If it's for mean, use the symbol mu. Now you can try the rest of them as a practice. Let's look at some other terms we use in hypothesis testing so that when we come back next week, we can now jump right into the testing of hypothesis. Level of significance. So the level of significance, which you also call alpha. You are familiar with that. I just give you examples with it. So the level of significance is the probability of rejecting the null hypothesis when it is true. So it is basically the probability of committing type 1 error. Now, the critical region can also be called the rejection region. And it is the set of all the values of the test statistic that cause us to reject the null hypothesis. Then critical value is basically the point on the test description that is compared to the test statistic in order to determine whether to reject or not to reject. Usually, if the answer is bigger than the critical value, you reject. If it's smaller than critical value, you don't reject. Now, I can see a two-tailed test. I already mentioned it at the beginning. You can see a two-tailed test. You can see that the critical region is on both sides, and in the right side on the left side. See, the yellow part is the acceptance region. You don't reject anything that fall in that yellow part. Now, for left-tailed test, we have this. So the left side. For right-tailed test, it's gonna be on the right side. Okay. Now, this give you the background information on how to state what hypothesis testing is about and how to test hypothesis. Now, when we come back next week, I will give you more. We'll now jump right into testing hypothesis. Before we leave, I want you to do this. Any question before we round up? Any question, guys? Okay. So the next question, I want you to, even though we are closing early, I want you to go through what we reviewed today on hypothesis testing and confidence interval for proportion. Practice as many as you can, because they will come out in the final exam. Everything will come out, this class will come out, but I will pick one question from each section or two questions from different sections. Now, remember, start your project now. So when we leave, there's no classwork, just your homework and the test and the project. Start working on those. And I will see you guys next week. Don't go yet. Let me check your names. Let me check your names. Makago. I have Makago and I got Rex. So Rex, are you still there? Rex, are you there? Okay. Rex is there. Any question before we leave?
No.
Okay. So I think I have 1, 2, 3, 4, 5, 6. So yeah, you are free to go now. I'll see you guys next week. But remember, start working on your project, your test too, and the homeworks. Semester is almost. I think after next week, I don't even think we need to come to class after next week. Okay. You have a good night.